and welcome to this episode of Weld.com. My name's Adam Stretch. I'm the program coordinator and one of the welding instructors here at Pellissippi State Community College in Knoxville, Tennessee. Our friends over at Everlast sent us a new piece of equipment. This here is the TIG 315LX. We're going to walk through some of the features, benefits, what comes with this. We have a regulator with hose. Kind of like that this is actually a flow meter style regulator instead of those, just the 2-gauge type regulators. This is going to be a little bit more accurate. We have a 10-foot work lead, your ground clamp there. It's pretty standard 35 DINs, twist lock type connection, and a nice spring-loaded ground. 10-foot stick stinger, standard 35 DINs connector, quick twist lock. That's pretty handy. Comes with everything we need to do some stick welding, but really you're buying this for the combination of the stick and the GTAW or the TIG welding process here. This one's got the Nova foot pedal upgrade. That's definitely a substantial upgrade from the older pedals. 25-foot cable and nice chrome plated connectors up here to hook this to the machine. This comes with a number 18 water-cooled TIG torch. Again, 35 DINs, quick connect, and the necessary air and coolant lines. This is a 12.5-foot torch. There are a lot of other torches available on their website should you want to upgrade. If you're doing a lot of work that you need that 25-foot range for. If you're welding relatively close to your machine though, no point in having extra cables to trip over. If you recall, a number 18 torch uses the same consumables as a number 17 or a number 26 air-cooled, your 150 or 200 amp air-cooled torches. So you'd be able to use all your standard collet bodies, gas lenses, keeps it nice and interchangeable. Hand control up here on the top, and that's going to give you your 2T or 4T operation, depending on how you set the machine up here. You can use that just as a hot button as your on-off switch, or you can use it to cycle through the 4T operations where you individually cycle through and ramp through that upslope and downslope. In case you didn't want to be running a foot pedal, you wouldn't be able to use the upslope and downslope with the foot pedal because you'd have the option to just put your foot up and down. But that is kind of handy if you're using a hand torch operation. Now let's talk about some of the features, benefits, and applications that this TIG 315 is going to be used for. This is more of an industrial piece of equipment where many of you may be familiar with like the Everlast TIG 185 or 210 EXT for the hobbyist or dual voltage users, or stepping up to something like that 255 EXT or MTS 275 machines. Those are more of a digitally controlled type application. This one's designed more for heavy industrial applications. You're going to be looking more towards construction. You could hook this to CNC automation, where you're going to be kind of setting the machine and using only 1 or 2 settings. You put some little marks, take your Sharpie, put a pen mark, where you find that it runs really well for the application you're using it for. Not something where you're going in and changing features all the time. The nice part with these analog controls though, is you don't actually have to go and search for which setting you're attempting to change. They're clearly labeled right here on the front of the machine. You can immediately identify which feature you are attempting to change and just change that feature. And you can do it with gloves on versus having to try and push buttons and do touch screens and menus. This is a AC/DC GTAW, so it'll run your alternating current for your aluminum or magnesium. It'll run your DC current, direct current in the TIG applications for carbons, stainless, chrome mollies, nickel alloys, titanium, pretty much any ferrous material you're going to weld on, ferrous and non-ferrous. This has got all the features you're going to be looking for. It's also SMAW capable, so you can run your 7018s. This particular machine has a on amperage for DC at 10 amps and on amperage at 20 amps for the AC side when you're TIG welding. The AC frequency is adjustable to 500 hertz, so you can go from 20 hertz to 500 hertz, and a cleaning percent balance from 20% to 80%. So if you have really dirty material, you can turn that cleaning action up, or if you've got nice clean material you're welding on, turn that cleaning action down. It has a pulser that's capable of 0.5 to 750 pulses per second. That's really helpful if you're welding on thin materials, anything that's really sensitive to warpage. And as you cross from the 0 to 100 hertz, where you're really kind of agitating puddles to help float dirt or debris out of a puddle, the lower hertz, you can really concentrate that arc. The higher you go in the frequency there, you can actually see the arc concentrate down a little bit more. It is portable, but this isn't a lightweight machine. So, you're probably gonna put it on a cart. It's not something I'm gonna throw over my shoulder and carry up a ladder, but it is portable if it needs to be. And it does come with a standard 50 amp welder plug on the end of it. Pulling off the wall, it's gonna be pulling between 31 and 35 amps. So you are gonna need to have an appropriate circuit to be welding with this. But if you've got everything hooked up, it should run great for you. Those areas you're gonna use this, CNC applications, you could hook this into automation, right? Because of its duty cycle. This particular machine has a 315 amps, 60% duty cycle. So that's a duty cycle, a little refresher. That's for every 10-minute window, that would be 6 minutes of arc-on welding time at 315 amps in the TIG welding side of this. If you drop down to like 250 amps, this machine's got a 100% duty cycle. That's full 10 minutes at 250 amps. And all of those ratings are coming in at 40 degrees Celsius, which is 104 degrees Fahrenheit. Now, if you switch over to the SMAW or stick welding side of things at 250 amps, this will run 35% duty cycle. If you go up to 200 amps, you'd still be at that 60% duty cycle again using the stick welding process. It's a lot of rods to burn. And the fan will kick on and cool it down, and you can pretty much weld all day long with this without a lot of hesitation. Some of the other advantages here is being able to adjust that AC balance, like I said, from 10 to 90%. Now, this does not have multiple waveforms in the machine. It comes standard with Everlast Advanced Square Wave. If you've used any of the other Everlast machines, it's kind of the go-to setting that you find really good travel speed, really do good cleaning action. They picked the best one and put it into this machine. Again, for this application, it's not for the guy that's going through and changing waveforms and everything. It's more of that industrial use, a little heavier duty. So we're gonna start with our stick welding. We're gonna insert that DINS connector into the electrode positive. There's a plus on this side and a minus on this side. We're gonna put our stinger into the positive circuit for most welding applications. So that'll be set up electrode positive. We will take our work lead, ground clamp for many of you, put that into the negative side, the terminal, and go ahead and clamp that to our table. All right, once you've got those leads all hooked up, I want to talk to you guys real quick about the start intensity and the arc force. Okay, start intensity, that's what many of you refer to as a hot start feature. Helps initiate the arc with the rod when it's cold or when your plate's cold, right? Comes on a little bit hotter than what you would have your amperage set to. And then your arc force, we hear the term arc force or dig. And what this is doing is as the machine senses the rod get closer to the plate and that voltage will decrease, it'll actually bump the amperage up in the machine just a little bit to make sure we don't stick our rod to our plate. If we're running something like a 7018, 7014, we want to go ahead and dial that back more like the 20 to 30 range. And this goes from 0 to 100%. That start intensity, that's 0 to 100%. Power buttons back here on the back side of the machine. It uses a large breaker. Machine comes on, we're ready to set this up. So if we were going to be using the stick welding process, we would select the mode. We are going to select stick welding. We can then set our amperage. Again, we can go to 250 amps, which would allow you to burn up to about a 1/4 inch electrode, and all the way down to 20 amps, which would allow you to run a 1/16 electrode, a very large range there. Let's see how this runs. All right, we're gonna run some 7018s. Oh, I got no complaints there. Boy, is that a smooth arc. Yeah, there we go. I'll take that. All right, as we set this thing up for the GTAW or TIG welding process, we're going to be using 100% pure argon. We're going to hook up our regulator and our hose to the back of the machine. Let's see what that looks like. We remove the cap, remove the protective seal. Make sure before you hook up your regulator, you crack that valve and blow out any dirt or debris that's in here. You don't want to blow that into your regulator. We're going to go ahead and attach our regulator here. Make sure that the flow meter itself is in a vertical position. That way that the ball is not trying to roll sideways and give you inaccurate readings. So we'll make sure that that's where we want it to be. Just snug it up. Remember, these are brass fittings. We don't need to hang from the wrench. It's just a brass fitting. We can take our air hose that is going to go from our regulator to the back of the power source. Go ahead and attach that. You're going to need two tools. You can either use your everything wrench, that adjustable, or an 1 1/8" wrench for the regulator to the bottom, and an 11/16 to hook up the rest of these hoses. Once we've got the hose hooked to the regulator, we can go ahead and feed the rest of it to the back side of the welder. The hose coming from the regulator off the bottle is going to attach down here into the gas inlet. Again, this is a brass fitting. You just need to snug it up. Don't get crazy on this. As long as we're back here, let's take a look at a couple other things on the back side of this machine. We have a grounding plug back here, especially if you're going into automated applications. You want to remove any electrical interference and ground that out. There's a place to do that on the cooler as well. The cooling fan is back here. Keeps the machine cool during operation. Your power switch is back here. It's a on-off breaker style. Power cable comes out from the right side of the machine. Your water cooler will plug in right here into this AC 240 volt plug. That's for the water cooler. Really, I want to take a look at the back side of the machine though, and this label. The nice part with this is this has been inspected and tested prior to leaving the factory. That means when it arrives to you, it's ready to weld. Somebody's already checked it to make sure it's good. You can also see the label back here. This is going to be your NEMA certifications. Okay, it's going to tell us that this is going to run on single phase power, 50 or 60 hertz, takes 240 volts, operating about 31 amps on a 240 volt circuit. Up here we can look at TIG welding in an AC format. We'll have our 60% duty cycle there at 315 amps or 100% duty cycle at 250 amps. We're pushing about 20 volts there. The trade-off, and so a lot of people don't understand this, is TIG welding takes a lot less voltage than your MIG welding does in this application. So because we get that bump in voltage, we reduce our amperage a little bit. That way everything balances out. So our DC, so that was an AC-DC sign. This is a DC sign on our stick welding. We'd have our 35% at 250 amps, running 30 volts. At 60%, we'd have 200 amps, and that's 28 volts. And at 100% duty cycle, we're down at 160 amps, which is burning 1/8 inch electrodes all day long, 26.4 volts. Well, that's how the back side of this machine reads. All right, now that we've got all those gas connections set up, we're gonna go ahead and set up the water cooler. Being a 315 amp machine, your torch will get hot. Now you can run an air-cooled torch with this setup. However, if you're gonna be doing a lot of welding as you would in an industrial application, you're gonna wanna go ahead and get the water cooler to go with this as a package. This particular Power TIG 315 will use the W400 water cooler we've got right here. This water cooler is rated to 400 amps. It holds approximately 2 gallons of coolant. You will want to use coolant that's designed for TIG welding water coolers. They have low conductivity. You don't want to be using your RV coolant or like automotive coolant or water. Now you can use a distilled water, but you really only want to use that for 2 to 3 weeks. If you were setting up a machine or doing some testing with one, we're going to go ahead and use appropriate coolant for this though. This is the antifreeze coolant. It comes pre-mixed. This one's actually from Miller, but you can use any name brand welder designed coolant. We're going to go ahead, fill up the cap. This will take approximately 2 gallons of coolant. The plug right here is going to plug into that back of the welder that we showed you earlier. That's going to finish the connection. This will turn on the cooler when you go to weld. Power switch is right here. You're going to want to turn that on, and your hot and cold returns will come right here to the front. There's also the window here to tell you where your coolant level is. And guys, when you've spent this much money on a piece of equipment that's going to make you money, go ahead and take care of it. I know the coolant can be a little bit expensive, but you've already made an investment. Keep investing just a little bit more. And then this is not a one and done type thing. You should change your coolant on a regular basis. Check your manual for those service recommendations, or at least once a year, go ahead and buy some new coolant. Flush out the system and put new stuff in here. Make sure that this is ready to run for you for years to come. Let's go ahead and get this filled up. We'll go ahead and get the coolant in here and get this rolling. All right, our coolant level is full. We are ready to finish setting this torch up. We're going to start by plugging the W400 cooler here into the back of the machine. That's going to be our power cable that plugs into the back. The torch is going to have these color-coded cables, the red and blue, that will be plugging in to the cooler, matching these quick connects. Blue on the bottom, red on the top. That's going to be your hot water, your return water, and the water that's been cooled through the cooler here. The black will be your gas line. That would be the argon gas coming through. Gas line plugs into the front of the machine here with another quick disconnect. You could use this without the cooler, but here we are setting up the cooler. We're setting this up for the GTAW process. Both the AC and DC versions, TIG welding on this machine is going to be done with the DINS connector for the torch plugged into the negative cable, and the work lead, or ground clamp if you will, plugged into the positive side terminal. So we'll go ahead and put the DINS connector in the negative terminal right here. Get that locked in. Just make sure the little tab's lined up. You can take the work lead, plug that in on the positive side, straighten out the leads, go ahead and clamp that to the work surface. All right, now that we've got the cooler all set up, we're going to finish selecting the amperage control or amp-trol that we're using. We've got two choices here. We can either use the torch mounted button here, which gives us a 4T option, and that's going to be able to use an upslope and downslope on-off type situation. We've got pre-flow, post-flow here at the top. That's how much duration of time the gas flows prior to initiating the arc. And then after we're done, how long the argon is going to continue to flow to make sure our tungsten, our filler metal, and our weld is cooled in an inert atmosphere post extinguishing the weld. The other option is to use a normal foot pedal here, and that's going to control our amperage from 0 to full amperage of whatever we have the machine set to. We don't have the 4T option, but that will be using this nice chrome plated connection. It plugs in right here in the front, in the middle. And if you're going to choose this, like I said, you don't have the 4T option because you don't need it. If you want to use the 4T settings, okay, you would have to use the torch mounted switch right here. It's going to work similar to a hot button, an on-off. So you could just use this as an on-off if you wanted to, or you can set the 4T setting up. Turn the welder on, turn the welder off, ramp up, ramp down. All right, let's get this set up. We're going to be doing stainless steel.
And I'm going to be starting out using the foot pedal. So I want full amperage. I'm not gonna have the 4T. I'm gonna go ahead and switch this torch head over. We're gonna set this all up to run stainless. So I'm gonna put a gas lens on here with a gas lens number 8 cup. I wanna be able to have a little bit more stick out so I can give you a better view of the arc. A little better arc shots come in with being able to stick the tungsten out a little longer. And so we're gonna have a little bit more gas flow. We also wanna be able to show you guys some of the pulsing features. We're going to be set up on DC welding, that's direct current electrode negative, to weld on stainless steel, the same way we would with carbon steel. We're going to go ahead and turn up the pre-flow, give ourselves a little bit longer pre-flow. Here we have an option to go from 0 to 10 seconds. We're going to turn the post-flow on as well. Get our post-flow up about 15 or 20 seconds. What we're really looking for is to make sure that everything is cooled down in that inert atmosphere. We've protected the molten weld pool and our tungsten well cooled. All right, we're set here on the DC arc, 2T foot pedal, and we're going to be doing this without pulsing to get started. Then I'm going to go through and turn on the pulser and show you guys how this works. We're going to set our base amperage. We're going to set our pulse time, our pulse frequency, and our background amperage. So the red dial here in the middle will be our peak amperage. Top button is going to be our background amperage, or the bottom of our pulses. And the pulses here are going to go from 0.2 to 25 hertz. So that's the frequency that we're pulsing at on the low setting. Then if I switch this over to the high setting, we can go from 25 to 750 pulses per second by adjusting this dial. It really helps narrow the arc and focus it up on a tight arc, where the low pulses can help agitate a puddle with some, if we had like a dirty casting, we can float some garbage out to the top. Somewhere in the 30 to 50 is a pretty good range to start. So if we set it at 50%, 50% of the time the amperage would be at the high amperage that we have it set to. 50% of the time the amperage would be at the low amperage we set it to, which means our average would be right there in the middle. So let's say you had it 50% at 100 amps, 50% at 50 amps, we would average then 75 amps.
Now, if you're on remote and high frequency or lift arc TIG, in this case we're using high frequency, I want to show you something though. If we switch over to the stick welding and I hit the pedal, the gas valve does not open, so I cannot check this regulator. So if you're not able to get your regulator to set, make sure that you are using the proper high frequency TIG setting, because without that, you don't get any gas to flow. And so we want to make sure we get our gas flow about 18 to 20 CFH for the cup that we're using here. I got my pre-flow, I got my post-flow. All right. Let's stack some dimes. Here we are welding. This is no pulse. This is just running a straight bead on a plate. Just trying out the amp. Getting us dialed in. Nice crispy DC arc here. I like it. I like it. Let's see what we can do if we add some pulse behind this thing. Maybe pick up some travel speed a little bit. All right, here we are at that low pulse setting. Let's see what that looks like. Picking up travel speed, reducing the heat input. Looking pretty good here. Feel like we got a little disco ball going here. Little party. Here we are at 350 pulses per second. Wow, that really tightens that arc up. Look how much smaller the bead profile is. It allows me to travel significantly faster and definitely get some of the heat out of this material, especially warp sensitive materials like stainless steel. I can get in here, run a little bit quicker on the bead. Definitely allows me to travel a lot faster and limit that heat input. All right, let's go ahead and max this thing out. Let's see what 750 pulses a second looks like. I'm again gonna leave those two at 50-50. Let's take a look. Woo, that's a distinct hum.
That really allows us to increase travel speed here. We can travel the same length of weld much faster by running that high frequency pulse. Oh, that's nice.
All right, as we can see here, this was no pulsing. This was just running a straight DC arc. Gave us a nice crispy looking weld, very smooth arc, no pulsing. That low pulses a second puts distinctive ripples inside the weld. Allows us to agitate the puddle if we were welding on something like a casting, help shake out any of the dirt or debris that might be in there trapped inside and float it out to the surface. But as we start to get in those higher pulses a second, that higher frequency, it narrows the bead profile down, right? It gets a little bit narrower. It allows us to travel significantly faster though. When we really crank it up, go to that 750 pulses a second, it allows us to get that same weld look, but it narrows down the heat, narrows the weld profile, narrower bead, tightens the arc up a little bit. As you can see in the video, we get a tighter arc coming off of it, but it really picks up our travel speed. And in industrial applications, time is money. And so by using something like this PowerTig 315LX and turning the pulsing up, we can get high speed work done while still putting down quality welds. Let's take a look at this in a lap joint. We'll set up a lap joint on some thinner stainless and see what that looks like. Here we are, we're gonna run a lap joint. I'm gonna run this backwards so you guys can get a good look at the arc. This is that high frequency, high pulses a second. Boy, can we lay down some really tight, crisp welds on this thin material, limit our heat input, limit our warpage, increase our travel speed, and allow us to really stack those dimes in there. All right, we're gonna switch over to AC. We're gonna do a little aluminum here. We're gonna turn that pulser back off. I'm gonna turn my frequency to 60 Hertz, and I'm gonna turn my cleaning action down to about 20%. I got nice, clean, fresh new aluminum to weld on. So we've got a range here between 20 and 80%, and that's our cleaning. Turn the balance towards the negative side of the cleaning. Let's take a look at it. It definitely allows us to travel faster. Woo, that sings. Frequency there back down to 120 Hertz, but we're gonna turn our balance up to 50% penetration, 50% cleaning. Definitely gives us a larger etching area. That's that more cleaning action, that's more time electrode positive. If you were using dirty material, you definitely want a little more cleaning action going on. Much larger etching area though in that aluminum. All right, here we are at 80% cleaning action. Well, we can barely weld there. All we do is ball up the tungsten. All right, on this 6061 aluminum, we started way up here. That's at 60 Hertz, real wide bead. We went to 120, we went to 250, we went to 500 Hertz, and then we turned up our balance, which is our cleaning action. As you can see, when you turn up your cleaning action, 50% cleaning action really increased that etchant area. At 80% cleaning action, we just put too much heat right into the tungsten, caused that tungsten to bald up. That was too much electrode positive for this material and that diameter of tungsten. All right, thanks for tuning in to this episode of Weld.com. Again, my name is Adam Stretch. Thank you for taking a look with this Everlast PowerTig 315LX. Very industrial machine. It's ready to take on any task, 7018s in the SMAW. Pretty much any material you'd need to TIG weld, either the foot pedal or the finger controls, 2T, 4T settings. You got your balance, dig, aluminum, magnesium, titanium, carbon, stainless, chromoly, whatever you can want to weld on, this machine will get it done. Water cooler kept the torch nice and cool while we were welding. Thanks again for tuning in. Touch base with us. Weld.com, on our forum, on our app. If you're looking for an industrial piece of equipment, got one right here. Everlast Welder 315LX. Thanks for checking this out.